Right, so here we're going to talk about what we call permutations and combinations. Okay, so first of all, let's talk about everybody's favorite, a factorial. A factorial is an operation in math, and its symbol is an exclamation point. When we have a factorial, right? So for example, here, when I have 8 factorial, that's not just like an excited 8, right? Like that's not what that is. That is, you start with that number and then you multiply all of the digits starting with that number down to 1, all of the integers, right? So 8 factorial is 8 times 7 times 6 times 5 times 4 and so on. The way we write that is, if you have n factorial, then it's n times 1 less n minus 1 times n minus 2 times n, etc. until 1. Now, another thing you have to remember is 0 factorial is 1, right? Just like, 5 to the 0 is 1, 0 factorial is also 1. Okay? So that's what a factorial is. Okay. Now, let's talk about a permutation. A permutation is when objects in a sample space are arranged so that the order is important. Each possible arrangement is called a permutation, and we use factorials for permutation. So, for example, let me give you guys an example. Suppose I said, going with this next example on a softball team. So suppose the coach on the softball team says, hey, send me 5 kids or send me 4 kids to help, bring the drinks over, right? And you tell the coach, okay, I'm sending over Erica, Jasmine, Tara, Becky, okay? Does it matter if you say it like that or if you say it, I'm sending over Tara, Becky, Jasmine, Erica? Does it really make a difference? No. Versus, look at this example. These people are on a softball team, and the coach wants to consider all the possible ways the 4 players could bat first, second, third, fourth. Now, it makes a difference whether I say Erica, Jasmine, Tara, Becky, because they're going to bat first, second, third, fourth, right? Or if I gave the, names in a different order, right? So that second example where it makes a difference, the order in which you say it, that is called a permutation. Okay? All right. So for example, another example is, if I pick, 4 markers out of this pouch, right? That's one thing. But then if I say, oh, look, I picked a green, a black, a black, a blue, a black, a blue, that's a different one, right? So there, the order matters. Okay, so let's talk about this then. Erica, Jasmine, Tara, and Becky are on a softball team, and the coach wants to consider all the possible ways they could bat first, second, third, fourth. Find the total number of permutations. Okay, so we have 4 slots to fill. Okay. And so if you just want to arrange them, like randomly, right? You're just like going to pick, okay, like this person, bat first and so on. So there are 4 possibilities for who gets to bat first. Then once that person is selected, now there are 3 possibilities for who bats second, 2 possibilities for who bats next, and 1 possibility for who bats the last. Okay? So what is that? That's 4 times 3 times 2 times 1, correct? Well, that's the same as 4 factorial. Okay? So 4 factorial, which is 24. Okay? All right. So here, Ray and 5 of it. Okay, so again, what if this wasn't just this? What if this was like, okay, you have, like this many students, like you have 4,573 students, and they all get in a line, what are the different ways that they all can get in a line? You're not going to write down that for that many number of students, right? So for that, we just go to blah, blah, blah factorial. Okay? Yeah. Okay, so Ray and 5 of his friends, 6 people total, go to see a movie. In how many different ways can they sit together in a row of 6 empty seats? So now there are 6 people, right? So imagine if you label them 1 to 6, one way is they're sitting 1, 2, 3, 4, 5, 6. Another way is they're sitting like 2, 3, 4, 1, 5, 6 or something, right? So there are many, many possibilities. Well, this is a classic factorial. This is 6 factorial, which is 720. Okay? Yeah.
If it was like Ray and 2 of his friends.
Then it would be 3 factorial.
But it's still in 6 seats.
Oh, no, then there wouldn't be 6 seats.
No, but like, what if, what, you know?
Okay, yeah, so 3 people are going to occupy 6 seats. Okay, that won't be a permutation. That's a combination, which we'll learn later. Because there are, like, the empty ones are repeats, right? So, yeah. Okay, so, by the way, so here is 6 factorial, right? Okay, so before we did 4 factorial, which we can definitely do by, like without a calculator, right? 4 times 3 times 2 times 1, we can totally do this. 6 factorial, what is 6 factorial? 6 factorial is 6 times 5 times 4, 3, 2, 1, which is 4 factorial, correct? So this is actually 30 times 4 factorial, we just found to be 24. So there are, like, different ways of, like, figuring that out, okay? All right. A teacher has 30 students in a class and wants to select 3 students to go up to the board one at a time, okay? How many different ways could this occur? So now this is different because the teacher is not calling all 30 people to the board. Only 3 people are getting called to the board. So let's actually write down the slots for this one. The first time around, there are 30 possibilities. Okay? Now, one person went and they can't go anymore. So the next time around, how many people are there to go? 29. And the next time is 28. And that's it. We're done picking. So that will be 24,360. Okay. So what is this? Okay. How did we come up with this? Well, basically, we started doing 30 factorial. Is that right? We started doing 30 factorial and then we stopped short. So imagine if you had done 30 factorial, what would you have had here? The continuation would be 27, 26, 25, 24, 23. So after this point, after the 28, what factorial do you have left? 27 factorial, right? So imagine you have 30 factorial. This would be 30, 29, 28, 27, 26, 25, blah, 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 all of those. Now imagine I divide this by 27 factorial, right? What would remain? Just exactly what I had. So this is 30, 29, 28, 27 factorial if I continue, right? Because it'll be 27, 26, 25, 24. Now I'm dividing this by 27 factorial. These things cancel out, so I'm left with the exact answer that I, came up with before. So what is it that I did? I had 30 possible people. Of that, I chose 3. How many people are left? 27. That's the factorial that goes on the bottom. Okay? So, if this is n, 30 factorial is n, and if I chose out of n people, if I chose r, then on the bottom I would do n minus r. Okay? And so that's where this permutation formula comes from. the number of permutation of n objects taken r at a time. I have 30 objects, 30 people. I'm taking 3 out of them. This is the possibilities. Now, there's a little bit of shorthand here. This is a permutation, right? And it's PNR. That's how it's written. And the formula is this first number factorial, the difference factorial. Okay? All right. So let's just do these now. 10 factorial over 8 factorial. Let's just figure out what this is. So this 10 times 9 times the rest of this will be 8 factorial, correct? Over 8 factorial, these two go away. This is just 90. Okay, so forgetting all the picking and choosing and the permutations, let's just do this. Okay, so 16 factorial. So this is 16 times 15 times 14 times 13 times, when I get to this number, I'll stop. 12 factorial over 12 factorial, 6 factorial. Okay, so what is 6 factorial? 6 times 5 times 4 times 3 times 2 times 1. So how much is this? These cancel, right? Can I reduce anything else here? I mean, yeah, like, look, the 5, I can reduce with the 15, and this becomes 3, right? What else can I reduce? There's so many. If the 4 and the 16, this becomes 4. What else can I do? The 6 and the 14. Okay, so you know what? Why don't I write this cleaner here? 4 times 3 times 14. Yeah, so many. The possibilities are endless. Right? So what else can I cancel out here? Okay, this becomes a 2. And then these 3's go away. Yeah? You guys see what I'm doing? And then what else? Oh, let me cancel out this 1, 2 with this 6, and this gets a 3. So what do I have left here? 14 times 13, which is how much these days? 182 over 3. Okay? Okay, so let's do this factorial. When I have this, okay, I have the first number factorial over the difference 5 factorial. And always things are going to cancel out. So 7 times 6 times 5 factorial over 5 factorial. This is 42. So here, 6 times 5 times, oh, let's write it out first. 6 factorial over how many factorial? 2. So this is 6 times 5 times 4 times 3 times 2 factorial over 2 factorial. Right? And that's 30 times 12, which is 360. Okay? All right. So let's move on. The librarian is placing 6 of 10 magazines in a school showcase. How many ways can she arrange the magazines in the case? 6 out of 10. So there are 10 total. We need to choose 6 of them, right? So it's a permutation. Out of 10 total, we choose 6. And now notice these 6 magazines are different, right? So if I like arrange them, right? If I have like, I don't know, what are some magazines? Vogue. I was going to say highlights, but sure, go with the fancy ones, right? Okay, so if I have like Vogue and then People and then sure, let's put in the highlights, right? In that order. Or if I have highlights and then People and then Vogue, those are different situations. So each one of those counts as a different arrangement. Okay, so this is going to be 10 factorial over how much? 4 factorial. So 10 times 9 times 8 times 7 times 6 times 5 times 4 factorial over 4 factorial. Now, rest assured, you are going to have your calculator with you on these, but I would like to see, if I say show work, I want to see you showing work like this. So this, when you put it in your calculator, guess how many possibilities there are, guys? 151,200 possibilities.
That was my guess.
Right? Imagine doing a tree diagram for that one. Whew, it'll take forever. Maybe I'll just like.
What's the biggest tree diagram you've ever done?
Oh, definitely not this.
What's the biggest one? Just off the top of your head.
I guess, I don't know, like the ones on the notes of the homework. Probably,
Really? Like
yeah.
4?
And nobody does more. I mean, that's just silly. It's silly. But maybe if I have somebody do like the one, I mean, that definitely deserves some extra credit, right? But
if I do like one with 100, can I get like 5%?
Oh my god,
credit?
I don't know. It might be like child labor or something. That might not be very legal.
I'm for 5% extra credit.
Okay, now. Okay, so all this was way too simple. So let's complicate things a little bit. Okay. What if there are permutations with repetition? Oh no, you don't even know what that means yet. Okay, so the number of distinguishable permutations of n objects in which one object is repeated r times, r1 times, another object is repeated r2 times, and so on is this. Okay. So n objects are repeated, right? So this is the formula. So for example, take a look at this. On a game show, you're given the following letters and asked to unscramble them to name a U.S. river. If you selected a permutation of these letters at random, what is the probability that would spell the correct answer of Mississippi? What I mean by that is, obviously you can look at it and there's like one answer, Mississippi. Okay, but what if I took all these tiles and I threw them up in the air and they landed? What is the possibility that they would spell out Mississippi? Right?
Very slim.
But I mean, so the thing is, right? Or if you do it another way, like imagine like these are all in a bag and you're blindfolded and you're picking out one at a time. What are the chances that you'll spell out Mississippi? Now, suppose, you go in there and like you choose M, okay? You choose that letter M. Now, whether you choose this I or this I or this I or this I, right? It doesn't matter, right? They'll still spell out Mississippi, right? So all of those are repetitions that we need to take out of the equation, okay? So how many total letters are there in Mississippi? No, letters.
4 different letters.
Oh, no, sorry.
There's 4 different letters.
There might be 4 different letters, but how many total letters? That's what I meant. 11. And I bet you have gone through your entire lives having never counted the letters in Mississippi. So there you go, right? Right, MISSISSIPPI, of course. No. So, yeah.
There's just no point in knowing it, so I just don't. Yeah.
So, okay. So it's 11 factorial. Okay, 11 factorial. But look, the I's, 1, 2, 3, 4, repeat 4 times. The P, how many times does the P repeat? Just 2 times? 1, 2, and then what else repeats? Oh, the S's. There's a whole bunch of S's. 1, 2, 3, 4 S's.
So if the 4s repeat, like, why can't the different letters?
Yeah.
The bottom is only the 3.
Hmm?
The bottom is only the 3.
Yeah.
Yeah, because 1 factorial, like 1 is the ultimate.
Right.
Oh, wait.
Like the 0.
Right. So The question is asking, what is the probability that would spell the correct answer? Probability, like before, it's number of favorable outcomes over all of the different possibilities. So this is all of the different possibilities to arrange these letters, okay? So for example, you could have MISSISSIEIE, okay? So close, right? So that's one of them. So this is a total of 34,650 possibilities. Out of those, only one is correct, and so the probability is very low. In fact, it's 1 over 34,650. Okay? We don't care. So it says probability, so this is good enough. Okay. Now, so this was probability. I'm sorry, this was permutation. Now let's talk about a combination. Okay, let's talk about a combination. A combination is a selection of objects in which order is not important. Okay, so let's think of, all of these. So for example, just like I said, I go in there, right, and I say, okay, I picked like 3 markers, and if I don't specify what color markers, right, then the order doesn't matter. So let's see if each of these is a permutation or a combination. So choosing 3 different pizza toppings from a list of 12. So here's how I want you to think about this. You chose the 3 toppings, okay? Now, once your pizza is made, right, and you want to take a picture of it, does it create different pictures if you chose the toppings in different order? No. So that is a combination. Okay, so you get the same pick either way. Okay. Choosing team captains for a football team. If you're going to have 2 team captains, like co-captains, does it matter how you choose them? Like, does it matter if they're like co-sharing this thing? It doesn't matter. So this is a combination. Choosing the first, second, and third place winner of an art competition. Okay, this is definitely a permutation, right? Because I can't mess up that order, right? 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 Thank you. Somebody should have yelled out permutation, not combination. I know. You gotta go.
Get famous.
Okay, so the combinations formula is written like this. Get it? C for combination. Again, is N and R. So if you have N, people, you're going to choose R of them. And now it's the first one factorial, the difference factorial, so far it's the same, divided by R factorial, because you are taking out all of the repeats, right? So if you have like a drawer and you're going to take out 3 socks, if you get 2 pink and 1 blue, it doesn't, like, the 2 pinks don't make a difference, right? Like, it's not like pink, blue, pink, and pink, pink, blue are not different things. You still have the same 3 socks. Okay, so let's evaluate this one. So, okay, fun fact, we are literally just doing these combinations and pre-calc honors as well, and I had to remind them of this, and they had forgotten and blah 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 and whatever. Okay, so the first one factorial, the difference factorial, the second factorial. So this is 8 times 7 times 6 factorial over 6 factorial 2 times 1. 6's go away. The 2 and the 4 and the 8 make 4. So this is actually 28. Yeah? Okay, let's do this one. 10 factorial over 5 factorial, 5 factorial. Right? So this is 10, 9, 8, 7, 6, 5 factorial over 5 factorial times 5, 4, 3, 2, 1. Okay, these go away. Okay, now look. Guys, look here. Look at what I'm going to do. In the bottom, look, I have a 5 and a 2. They cancel with the 10. Right? Okay, what else can we do? Okay, so let's do 9 since I heard that first. And then this 4 and 8, I get a 2. Okay, so what do I have now? In the numerator, I have, so 36 times 7. Oh. Over 1. What's 36 times 7? I think it's 252. Well, let's see. No, I definitely know. Because 7 times 30 is 210, and 7 times 6 is 42. Well, that's how you do it. 30 times 7 is 210. 6 times 7 is 42. 210 and 42, 252. That's how they teach it in Common Core. Yeah, who says that? Oh, see, we can get along. Yeah, I never give my kids answers. Like when they tell me, hey, you know, Mom, is 6 times 7 42? I'm like, oh.
Maybe.
Maybe. What are the possibilities? Right? Okay, a department store manager wants to create a display for 3 mannequins. Do you guys even know what that word is? Mannequin? Yeah, okay, all right. I don't know. I was like, I feel like it's an outdated word. How many ways can she choose from 20 different shirts? So we have 20 shirts. We're going to put 3 on 3 mannequins. So it's basically, you know, a combination from 20. We're going to choose 3. Okay, so go ahead and do this, guys. On your mark, get set, go. Okay, so this is definitely, this is 20 factorial over 17 factorial, 3 factorial. This is 1,140. Okay, now I'm going to give you exactly 60 seconds and I want you to work out number 10. Okay, on your mark, get set, go. Okay, so if 3 points are chosen randomly from those named on the rectangle shown, what is the probability that they lie on the same line segment? So first of all, how many total points do we have? Right. And of those, how many are we choosing? 3. Oops. So this will give you 56. And now, what is the probability that they lie on the same line segment? Okay, so right, there are 4 places that it could lie on, so it's going to be 4 over 56. Okay, and then you simplify that.
On each side, 3 points are on each side of the rectangle, so there are 4 ways in which all 3
Right.
points are on the same side.
There are 4 ways that, okay, all right. So a teacher wants to form a committee of 5 students from his 32 student class. How many ways can he choose the committee? Is this a combination or a permutation? It's a combination. He's going to choose 32 out of, okay, so now go ahead and take out your calculators. You ready? Now, so this is, how much is this? This is 32 factorial, right? Over how much? Times 5 factorial. Okay, so let's go over here. Okay, so 32. All right, so look over here. This, the button right next to the 9. Is it over here? Or is it in? Huh? It's the book, the one next to it, the book. Okay, here you can find the factorial in here. Okay, but hang on, it's also somewhere else. Okay. All right. So there's an easy way to get it.
Oh my god, amazing.
Where is it? Oh, yeah, here. Okay, so that's annoying though, right? To do it every time, but let's, since we're committed, let's just do it. In parentheses, 27 factorial, 5 factorial. Okay, what do we get? Yeah, it's a big number. Okay, now, you guys ready? I'm going to show you something else. That the reason why I don't readily know where the factorial button is. Press menu. Go to probability number 5. Go to, okay, the factorial is also there by the way, but I don't want the factorial. Go to number 3, combinations. And here, let's put in 32, comma is to the left of the O, 5. To the left of the O at the bottom, 5. Press enter. Wow. Wow.
Oh my goodness. Oh wow.
Okay. So, oh.
Oh, I kind of like it.
Okay. A password is formed. A password is formed by 4 different letters from the alphabet. What is the probability that someone guesses the password on the first try? Is this a permutation or a combination?
Permutation.
It's a permutation because if the letter is, because if it's A, B, X, Y, right, that is, okay, choosing those 4 letters, okay, that's, oh my God, time is up. So this is a permutation, 26 to 4. Here, look, let me quickly, oh my God. So here, let's go to menu, probability, let's do permutations. How much is this? 26 comma 4. Oh boy, a whole bunch of possibilities. But the probability is 1 over that lovely number. All right? And the homework is a worksheet. Yay!